students, today we are going to discuss about T representation of two-port networks. Let us see. In the case of T representation, we will be representing the two-port network by using T. That means there will be different components such as ZA, ZB and ZC. It is in the form of a T. So, a two-port network with any number of elements may be converted into a two-port three-element network that is shown in this figure. So, this is like an equivalent T shape. So, in the case of T network, the impedances are ZA, ZB and ZC and that are arranged in the form of a T, and here the input port voltage is V1, output port voltage is V2. Input current is I1, output current is I2 and the ports are marked as 1, 1 dash and 2, 2 dash. Let us see. And here we are going to represent this parameter, that is ZA, ZB and ZC, that are the T element networks, T elements in the T network. Okay. So, we are representing these parameters or ZA, ZB and ZC in terms of impedance parameter. What are the impedance parameters? Z11, Z12, Z22 and Z21. Okay. So, we are representing ZA in terms of those impedance parameters, ZB in terms of impedance parameter and ZC in terms of impedance parameter. So, first of all, we have to write the equations for input port voltage and output port voltage in terms of currents I1 and I2. That is the set parameter representation for the input port voltage and output port voltage. So, that is our first step to get the value of ZA, ZB and ZC in terms of various impedance parameter. So, we know that V1 will be represented as V1 equal to Z11 I1 plus Z12 I2. V2 will be equal to Z21 I1 plus Z22 I2. That is our set parameter representation of voltages V1 and V2 in terms of I1 and I2. So, by rearranging that equation, we will be getting different set parameters. I am not going to the detailed steps because we know how to solve to get this Z11, Z21, Z22 and Z12. See, impedance parameters are called open circuit parameters, impedance parameter, because we are getting different values of Z11, Z21, Z22 and Z12 by open circuiting the ports. See, Z11 is obtained by open circuiting output port, that is by setting I2 equal to 0. Z21 is also obtained by I2 equal to 0. Z22 is obtained by I1 equal to 0. Z12 is obtained by I1 equal to 0. So, whenever I2 equal to 0, that means this branch will not be here. So, Z11 equal to equation V1 by I1. So, V1 by I1 means voltage is obtained. This voltage will be the sum of the voltage across this. So, ZA plus ZC into I1 by I1, that will be equal to ZA plus ZC. Z21 equal to V2 by I1. So, V2 is this one and I1 is current through this branch, and we will be getting this by I2 equal to 0. So, Z21 equal to V2 is what is V2? V2 equal to ZC into I1. So, ZC into I1 by I1, that is equal to ZC. Similarly, Z22 and Z12 are ZB plus ZC and this is ZC. So, we have the values of different parameters. So, by rearranging all these equations, we will be getting ZA, ZB and ZC. That is simple mathematical calculation. So, we will get ZA equal to Z11 minus Z21. Here, whenever we are taking this equation, you know that ZA equal to Z11 minus ZC. What is ZC? ZC is equal to Z21. That is, we are getting this equation. Similarly, we will get ZB equal to Z22 minus Z12, ZC equal to Z12 minus Z21. So, this is the set parameter equation for the T network. So, you remember this equation because this will be useful for solving problems. Sometimes you are asked to find the corresponding T elements by using the set parameters. You will be given the set parameter values and you are asked to find the ZA, ZB and ZC. Here the T network representation is this one and you are asked to find ZA, ZB and ZC. So, you should know this equation, then only you can substitute different values of these parameters. Okay. So, this is the main equation in the case of T network. Okay. Similarly, we can formulate an equation for ZA, ZB and ZC in terms of ABCD parameters, that is A, B, C and D. Let us see the calculations. See, we know that in order to formulate a relationship between this T network and this ABCD parameters, we have to first use the equations for V1 and I1. We know that in the case of ABCD parameter, we will be representing V1 in terms of A V2 minus B I2. Similarly, I1 equal to C V2 minus D I2. So these are the equations. So here when you are putting I2 equal to 0, A will be equal to V1 by V2, that is I2 equal to 0. B will be equal to V1 by I2, that is V2 equal to 0. Similarly, C will be equal to I1 by V2 and D will be equal to I1 by I2. So these are the equations, okay. Whenever I2 equal to 0, what happens? I2 becomes 0 means that the circuit will look like this. See, actually this was the, see, this is the circuit diagram. Whenever I2 equal to 0 means this part will be open. So this will not be here. That is, rest of the circuit will look like this. So well, I2 equal to 0. So we have to, in order to find out A, V1 by V2 is there. V1 is here. V1 is ZA plus ZC into I1, and V2 is ZC by ZC into I1. So we can write the equation as A will be equal to ZA plus ZC into by ZC. So that is equation for A. Similarly, we can find the value of C equal to I1 by I2 by I1 by V2 by using the same circuit diagram. In that case, what is I1? I1 is I1 itself, and V2 is, we have know that V2 is equal to I1 and ZC in the previous equation. So that is obtained 1 by ZC. So C will be equal to 1 by ZC. Similarly, whenever V2 equal to 0, we will get the value of B and D. So whenever V2 equal to 0, circuit will look like this. So ZC and ZB become parallel whenever V2 equal to 0. So here the equation for B is minus V1 by I2, and V1 is obtained by, you know that what is V1? V1 equal to the voltage across this terminal will be equal to current, total current into equivalent impedance. How will you get equivalent impedance? Equivalent impedance is impedance that is obtaining when we are looking the circuit in this point of view. So here ZC and ZB are parallel, that in turn series with ZA. So you will get the Z equivalent value will be equal to ZC ZB divided by ZC plus ZB plus ZA. So when we are rearranging this equation, we will get Z equivalent in this form. So we can substitute that value here, and here minus I1 by I2 will be there, and the rest Z equivalent is this term. So here we need to find out either I1 or I2. You know that in this circuit I2 is in this direction, I1 is in this direction. So there is a relation between I1 and I2. When we are applying current divider rule, we will be obtaining the relation between I1 and I2. You know that whenever you are applying current divider rule, you can see that you can find out the current through this branch, okay. So that will be equal to I1 into ZC divided by ZC plus ZB is the current through this branch, and that current will be in opposite to that of I2. So you can write the equation as I2 will be equal to minus I1 into ZC by ZC plus ZB. So we can substitute this value in the equation for B, this equation. See, this equation you can substitute the value of I2. So you will get, when you are substituting, you will get common terms cancelled out. So you will get B will be equal to this one. You can rearrange this equation. So you will get B as this one. See here, this is the equation, and in this case when you are multiplying the bracketed terms, you will get the equation like this. And here when you are dividing by ZC, you will get ZC cancelled out. So finally you will get ZA plus ZB plus ZA ZB by ZC. So this is equation for B. Next you want to find out the value of D. D also obtained in the same manner. Now we have the equation for I2. So you can similarly substitute the value of I2. So you will get D equal to ZC plus ZB divided by ZC. So what is your aim is, you have to derive the equation for ZA, ZB and ZC in terms of A, B, C, D. So then by rearranging the equation for A, B, C, D, you will get the equation for ZA as A minus 1 by C, ZB equal to D minus 1 by C, and ZC equal to 1 by C. So this is your equations of interest, because you are asked with the problems to find the value of ZA, ZB and ZC in the T network in terms of A, B, C, D parameter, because you are given by the A, B, C, D parameter, and then you want to find ZA, ZB and ZC. So this is all about T network in terms of A, B, C, D and Z parameter. Thank you.